Okay, I'm having a break from doing robotics videos, probably until fall. It's too nice weather to be inside doing robotics. So this video is about Node-RED. It's going to be a talk I give to the Technophiles of Mainline in a month or so. So Node-RED is based on Node, and it's a visual programming environment you can work on your web. And a lot of people use it for automation, so it can take in inputs, process them, send outputs. Just a nice little visual programming language. So here goes. Okay, just got a couple of slides just on some background to what Node-RED is. So let's have a look at this. So Node-RED, it's a visual programming environment. We can have a look at it in a sec. It runs on top of Node.js, which has some advantages for portability and ability to do asynchronous, non-blocking activities. And it was originally developed by IBM. You access the Node-RED editor via a browser, which just makes it easy to work with. You can sort of work from any browser, connect to Node-RED environments that on other machines, other servers and things. And there's many ways to host Node-RED, again, because it's built on top of Node. Node runs in many places. So some examples of places you can host Node-RED, Windows and Mac machines, Raspberry Pi. So if you want to have sort of a hardware device that's got some sensors and Node-RED's sitting in the middle, looking at those sensors and doing some activity based on those sensors, Raspberry Pi is good for that. Surprising one for me was it also runs on Android, so you can install Node-RED on Android, get access to many of the Android functions like the compass and the microphone, most of the things that are on a typical Android phone. Use the Android phone as a sensor source and then have Node-RED process them. Activities. I can also get access to some of the applications in Android as well, so useful way to run it there on Android. You can run it on Linux. I've got it running on Ubuntu, but it runs on almost any Linux flavor. You can run it within a Docker container. You can run it on various pieces of cloud infrastructure, so it runs in AWS, IBM Cloud, Microsoft Azure, so they've all got services that are specific for Node-RED, and you can also run it on places like Google Cloud if you're just running on processing Node that you've set up there. Node-RED's got a big community. It's open source, has lots of interfaces and libraries that are being built by people, again, because it's based on Node. The underlying components have been built using Node and JavaScript, because Node uses JavaScript, and there's many interfaces to common platforms already set up, so interfaces to things like sensors and common services, things like email, SMS, TCP, HTTP, just about anything that you'd want to use. So very easy to add things into your Node application because a lot of things are already pre-built. And the reason for using Node is it's ready for a rapid development of automation projects. Typically you don't want to do a lot of coding, you just want to connect things together, see how they work, particularly for things like IoT applications or home automation, where you've got sensors and devices that do things already set up and you just need a piece in the middle that orchestrates all that. So Node-RED's a nice way of doing that, and then down the road you can always convert the thing into a node or another kind of application once you've got the flows working correctly and you know everything's going to work. But you can even leave it in Node-RED, and that can be your control point for IoT applications. And another good thing about Node-RED is it allows you to focus on the logic rather than detailed coding of the application. We'll see in a sec that it's a graphical programming environment that makes it really easy to connect things together, and you can just think about how things should be connected together and what each piece of the flow puzzle should do, rather than worrying about the actual underlying programming language or the mechanics of how you do things. And finally, it's excellent for event-based, message-oriented and asynchronous use cases. So again, for automation activities where you just want to have something trigger some activity, something respond to that activity. So easy to set up those sort of flows. And just having a look at my setup. So I actually installed Node-RED. I've installed it in various places. I've had it on Docker, I've had it on Raspberry Pi, but now I'm running it on an Ubuntu VM on my NAS, on a Synology NAS, and that seems to be working quite well for me. So when we get into some of the examples later on, you'll see that's what I'm using for hosting my Ubuntu, my Node-RED instance. Because it's inside my home network, it can see everything that's going on inside my home network. So sort of, I don't need a Node-RED instance out on the web, but if I wanted to do that, say where I was coordinating between remote sensors and things, that's where I may host it on something like AWS or IBM's cloud. Just have a look. I can access my Node-RED environment, and you can see an example up in the right corner just by putting in a URL to my Synology NAS Ubuntu VM instance, and Node-RED usually gets or the editor usually gets exposed on port 1880. I did try a Docker install. I actually ended up preferring installing it on a VM or natively on Ubuntu or Linux, just because I don't have to worry about managing the port mappings that you need to do in Docker. But Docker's a good option as well, but you just may have to open some ports depending on what you're interfacing your Node-RED to. And finally, I got up to speed with Node-RED by doing a Udemy course. I like to do these because they're usually pretty cheap. This one was actually $16 when Udemy was running specials, but I found it really good, so I got the link down there to the course that I used to get up to speed with Node-RED. Now let's have a look at some examples. So first, going to jump out of this presentation and look at the editor and see what happens when you just set up a basic flow. Okay, let's start using the Node-RED editor. So I've connected to my local copy of Node-RED on port 1880. This is what normally comes up, so I've just got an empty workspace editor here at the moment. The actual editor is made up of 4 areas. So one is the header up here on this line. The most useful thing you'll use the most is the deploy button here. It also has a drop-down menu of additional things you can do. On the left-hand side is the palette, which has various Node-RED nodes available for you to use, and you can add to the palette as well. The center part here is the workspace, so this is where you actually build flows, which are activities that your Node-RED application will do. And finally over here is what's called the sidebar. It has various functions, but allows you to get more details on something you select inside the workspace here. So if I selected a node, it'd show me more details about that node. Also allows me to do things like get debug messages and do additional activities associated with the nodes. So let's put together a quick Node-RED flow. It'll give you a better idea of what Node-RED does. So I'm going to use this inject function, which basically allows you to manually inject a message into a flow to get things started. Typically what you do is you'll be receiving data from external sensors or buttons or switches or something like that. But for testing out a flow, this is a good way to start. And I'm also going to use this debug node to display the results. So if I just tie these two together, and this is kind of the whole point of Node-RED, is graphically wiring up programs by selecting node functions from the palette and wiring them together however you want. So for this timestamp, I may want to set some details about it. So this is where you can see the the details are being displayed, and I think I just want to have a string being outputted in the message for this topic, and that message will be sent on to this message payload debugger, which will display in the debugger form here. To run a node in Node-RED, or to run a flow, you just deploy it. That's now deployed. If I press the button on this injector, you'll see how here in the debugger it shows that this on message was passed to the debugger. So that's one thing that's not very interesting. So let's show the sort of things that you can do with Node-RED. So you can add functions in, so things that happen to the messages as they pass through your flow. So let's try this delay one. That should be an easy one to work with. I'll connect that up so that when I press the button, that message gets sent onto this delay for 5 seconds. Let's change that, have it run a bit faster. So just delay the message for 1 second and then hook that back up to our debug display. Let's clear out the contents of our debug log, redeploy this. Now when I press the button, there's a 1 second delay before it displays on the message payload. So you can do lots of things with these functions here. You can actually build JavaScript functions to do things. You can switch, you can do all sorts of things with the messages, or as the messages come through here. So great for working with, say, sensor data, doing different things based on what that sensor data is. So let's have a look at a more complicated example. Okay, this next example is a bit more IoT. So first have a look at, I made basically a Wi-Fi button, a bit like Amazon's old dash buttons, where I could, you can see it down here, where I can press a button that sends a Wi-Fi request that in this case is going to go to my Node-RED instance. So in the Node-RED flow this time, I'm going to add an HTTP node to receive that request. I'm going to format a message and then send that message on to Twilio, which is a SMS service, and then we can have a look at it being received to my phone. So let's have a go at that. Okay, first let's have a real quick look at the IoT hardware to make this Wi-Fi button. So basically it's an ESP32 development board, gets powered by USB power, and I've got a connection between ground and GPIO pin 16 that's going to detect when this button gets pressed. Let's have a quick look at the code. Okay, and the code running on the ESP32 is real simple. It's MicroPython. It uses this microweb CLI library to actually send HTTP requests. What it's doing is for GPIO pin 16, it's setting up as a pin in and it's pulling it up. So by default, it's going to have a high voltage. So that's P16 being assigned, and then I sent an interrupt routine assigned to that pin 16. So if the interrupt is a falling request, which is when I press the button, it calls the button press handler up here, which is this thing here. So this gets fired every time the button gets pressed. One thing I added in was a 200 millisecond delay between presses, so it just debounces the circuit. And the important thing here is this content bytes, so it's sending it to my Node-RED instance 192.168.1.115, port 1880, which is the Node-RED port, and it's sending it to a node called red, and that's the contents of what it's sending. Okay, have a look at what my Wi-Fi button does. So this is my Wi-Fi button control, just running on an ESP32. If I push the button, you see in this network trace that it's sending a GET up to my Node-RED instance 192.168.1.115, and it's actually returning not found because at the moment I haven't got my Node-RED flow set up. So I'm in my Node-RED workspace. Again, it's running on the SNES Ubuntu machine. So I'm going to bring some of these nodes in. So I'm going to use an HTTP in this time instead of the the manual inject, and I want that just to respond to HTTP requests coming into the red node level. I'll put a debug message in because I just want to see what's coming in, and also I need to respond to the HTTP request, so I'll use this HTTP response. And so after it gets a request, it should respond. We're in debug mode. You'll notice that these little blue dot means that this flow hasn't been saved yet, so when I deploy it gets saved. And now when I press the button on my Wi-Fi button, we can see this message payload gets recorded, and this is the message that was coming through. So that's looking good. What I need to do is add in some logic to write out to Twilio, so let's do that. At the moment I don't have a Twilio node among the nodes available to me, so I need to bring one in. You do that by going over to this header menu, the manage palette, and I go over to the installs, and I can do a search and see what Twilio nodes are available. I think I'm going to use this one. Looks like it's fairly popular and fairly recent, so let's install that. Hit install. So it's added a couple of Twilio nodes to my palette. So let's close that and go have a look at how you use them. So this Twilio out one is the one I'm going to want to use. So double click on that. So I'm actually going to have to do two things. So I'm going to have to set up a connection to the Twilio API, which will take my Twilio service information. So let me bring that up. So it's going to ask for my account SID, my token, and a name for it. So I'll do that. I won't show you that part, and then we can put in the actual details for the Twilio message. Okay, I set up my Twilio account, so let's fill in the rest of the detail. So my Twilio account has the details for my account in it. I'm going to send an SMS message. I'll put in the address of my phone. Okay, we should be all ready to go. Here's my button, here's my phone. Let's try, and here goes. I got a message on my watch, and here we go. We got a message coming in from my Twilio as well. So that looks like it's working. I can also add in things like a message formatter in between. So if I want a specific message sent out to Twilio, I can put that into the payload and have that sent out. This third example, have a look at home automation, and this is probably a more typical use of Node-RED, so having it to respond to things that are happening in the house, turning things on and off, adjusting things. So it could be your AC, could be fans, it could be lights, garage doors, anything in the house that's been set up as a home automation target. In this case, I'm going to use one of these TP-Link caser switches to turn a light on and off when I press the Wi-Fi button that I set up earlier. Okay, this may be an example of rapid development as well, so let's see how we go. So I'm going to need a couple more controls or nodes to get this scenario working. So I want to be able to click on my button here again. So press that, you can see in the debug window it receives the HTML request. At the moment it's just doing a return of the value. So a couple of things I'm going to need. So I'm going to be using a TP-Link smart plug that's Wi-Fi connected. So I'm going to need a control or a node for that. So I'm going to manage palette, and I'm going to look for TP-Link. That one looks good. So we'll install that. So I've got a control for working with my smart plug. It's actually got a brand name of Caser. The other thing I need is when I click on the button, I want it to alternatively or toggle between the light being on and off. So I'm going to need another node, or I can use another node for that rather than writing the code. So again, manage palette, install, and let's go look for some sort of toggle. Toggle function, and we'll try that. Try this one here. So let's grab toggle first. So it's been added to the functions. So I'll put that up there and wire these together. And it's not too hard for setting up, just to flip between on and off. So I want to output a Boolean value. That's what's the TP-Link switch is going to use. So one's going to be true, one's going to be false, depending on what values are sent through. So that should be set up, and let's put the TP-Link Caser control in here as well. We'll wire that up, and it sets the values. So it can actually search your local network and see if there's any smart switches out there. And this test one's the one I'm going to use. It looks good. I think we're all ready to go. So let's deploy it. Okay, it's already recognized that smart switch, realized it's off. And let's try pushing the button. Success! So my light turns on and off, which is connected to that plug. And you can do a lot more complicated with things with home automation, put more logic in there. Let's have a look at one more example. This fourth example is another typical use case for Node-RED, where you want to do some data logging of IoT or other sensor measurements coming in, usually to record time series data, so see changes in values over time. So for this example, I'm going to use a time series database, this InfluxDb. So I'll add a node in to be able to connect to InfluxDB, and I'll record the values of my of whether my lights turned on and off and what time they got turned on or off from the previous example, and record that into the InfluxDB database. Then we can have a quick look at the data in the InfluxDB database. Another typical thing people do will be to have some sort of analytics program running over InfluxDB, so you can see the data sort of over time as a graph, and Grafana is a typical tool that's used for that. I'm not going to show that part. I haven't set up Grafana yet, but there's lots of examples out on the web of InfluxDB used with Grafana as well. So sort of once you've captured the data, then you can analyze it in different ways and graphically. Okay, I'm going to add some data logging to my script I was just using. To do this, I need to add the InfluxDB and the InfluxDB node to send data to the InfluxDB. I won't go through the install of the InfluxDB. Down in the description I'll put a link to a nice little video that shows how to install it on Ubuntu at least. But it's fairly simple to install, and also did a create database demo one, so there's a initial database set up in my InfluxDB setup. I've got InfluxDB running on the same Ubuntu server that Node-RED's running on, so it's easy for Ubuntu to find it. So first let's add the node to use InfluxDB. So I go to Manage Palette again, install, let's look for Influx. So this first one's the one I'm going to use, so I'll install that. So it's added a bunch of nodes. They're all under storage. I'm going to use the influx out because I'm going to write data to the influx database. Let's double click on that. So I want to connect to, put in the details of the database that I'm going to connect to. Because it's running on the same host, I can just use the loopback address here. That's the standard port. The database is going to be demo01, the one I set up. Put in my credentials. So now I've got a server set up, so I'll connect to my local InfluxDB. I'm going to give a name to my measurements that I'm going to write out to the database. Should be good. And I'm going to take the output from my toggle node last time, which is simple Boolean true or false in the message, and that's going to send it to this demo1 toggle. Let's deploy, and I'll push the button. So I'm not getting any error message, so now I can connect into my InfluxDB, see if it sent any data out there. Okay, now I'm connected into my Ubuntu server that's running the InfluxDB. Let's do a influx to connect to the influx client. I'm going to say I'm going to use database demo01, so I can use demo1, so I'm connected into the demo1 database. And that shows me what measurements have been written to the database. So there's one called toggle. So if I do a select star from toggle, so it shows the one value that I just wrote out to the database. That's the timestamp. I can do a precision RFC 3339. I should set the time zone to use. Now if I do a select, it shows a more readable time there, and the value was true. Let's try this, pushing this button a few more times, and check my lights turning on and off, and see if it's recording the values. So now when I do a select star from toggle, you see the timestamps next to the values that it was set to. And that ties in with saving the data or logging the data out of this toggle control. So that's kind of an easy example of writing IoT data out. Most of the times you'll be receiving sensor data, so maybe temperatures, humidities, all sorts of things, whatever your IoT device can output. In that case, you can format the message going to this InfluxDB output with different values that you want to write out to it, and then it'll be the same thing over in the database. You get all the values being written under a certain measurement name that you can then process. And I'm not going to do a demo of it, but Graphenid seems to be a common graphing program that people use with Influx to do this. So I hope you enjoyed this. This is the walkthrough I'm going to give to my Technophiles of Mainline meetup group, probably in a week or so. It's probably going to take longer than this without all the editing to get it done. But Node-RED has been pretty useful to me, and makes it an easy way to wire up IoT and home automation things.